Yellowstone Supervolcano warning, as giant magma chamber beneath the surface has been found by researchers. This is today's article. Yellowstone is sitting atop a giant magma chamber being fed by a volcanic plume hundreds of miles deep. Yellowstone is located in northwest Wyoming. It's one of the world's few supervolcanoes. Actually, not few, there's 21 plus. We've also have another one in Antarctica, another one under the Aleutian Islands of Alaska, and of course one under Italy. Now, the volcano here, Yellowstone, has had an eruption with a volcanic explosivity index of 8. The two last eruptions were the biggest. Now, in the last 3 million years, it's experienced 3 eruptions, the last coming around 630,000 years ago, and that was 1,000 times bigger than the 1980 Mount St. Helens volcano eruption. Its calderas, the large cauldron-like hollow forming after a magma chamber is empty during an eruption, lie over Yellowstone hotspot under the Yellowstone Plateau. And this is where the light and hot magma from mantle rises towards the surface, with a hot spot underneath the surface so deep that the North American plate slides west-southwest over it. Now, the video before this one, you'll see that we have the GPS that we're looking at the deformations going southwest, and it's inflating around the northwest Wyoming, over the caldera, and especially over Hebgen Lake. Now, over the past 16.5 million years, this hotspot has generated a succession of explosive eruptions, but less violent floods of basaltic lava. Today, scientists and researchers are closely observing Yellowstone for signs that it might be gearing up to explode in the near future, especially a super eruption. It's generally accepted that an eruption in the next 10,000 years is very unlikely, and scientists have found no imminent smaller eruption of lava in more than 30 years of monitoring. But it has not stopped field workers studying this caldera, and they're creating cutting-edge graphics and models with data harnessed from the volcano, also from the GPS and satellites, also explored during the Smithsonian Channel's documentary titled Yellowstone Supervolcano. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. In 2015, the scientists collected new data, and it gave them the best idea yet of Yellowstone's underground plumbing. Identifying the magma chamber of Yellowstone from the last eruption, that's how they discovered how it was being fed by a plume of magma stretching down 465 miles northwest into Montana, mostly solid rock, but with the potential to liquefy. And using that data, researchers created a graphic showing a giant yellow stalk shooting off into the ground far away from Yellowstone's surface. It's through the plume that magma or molten rock is rising into the magma chamber at a rate of a whopping 2 inches a year. So it is inflating at least 2 inches a year. There's no reason for this process to stop, they said, and eventually it will continue until the pressure becomes too much and the volcanic eruption occurs, or it could come in short, sharp spurts. Yes, and I have posted videos concerning geologists finding that it may not take hundreds of years for a supervolcano to erupt, but may take decades only. Now, while this is unsurprising, the pressure becoming too much and an explosion, eruption taking place, what scientists are paying close attention to is the liquidation process. The real danger comes when the plume starts liquefying and moving up at a faster rate, filling the chamber. On erupting, Yellowstone's magma is unlikely to turn into lava because the intensity of an eruption would force most of it to shoot into the sky, and that's not going to be good, obviously. It would then take on the form of airborne ash particles, small, extremely hot pieces of jagged rock, and this event alone would affect nearly all of the United States and Canada, with tens of millions of people within a 621-mile radius or 1,000-kilometer radius, at risk of death, of course. And always, we're talking about a super eruption in this case. Now, we have had lava eruptions, the last one 70,000 years ago, and another 80 eruptions since then. Now here, concerning the supervolcano, super eruption, once the ash is breathed in, it would form a cement-like mixture in people's lungs and cause suffocation, just like we saw that what happened in Vesuvius and Pompeii. Now, while those outside the 1,000-kilometer or 620-mile radius may be safe from immediate aftermath of an eruption, a centimeter of ash would still have fallen, still a dangerous level for human lungs, obviously. Even Europe would get hit with some of this ash, while the rest of the world would experience climatic changes. Global temperatures would drop by about 10 degrees Celsius and stay that way for at least a decade. So you can imagine how devastating that would be for production and crops and animals. Things like crops and water supplies would also be severely affected. Some scientists and organizations have spent years hatching plans to stop any future Yellowstone eruption from ever occurring. NASA spent significant time working on solutions like increasing the amount of water inside the volcano with a view to extract heat from it and so reduce the risk of a buildup of pressure. But many have said that in reality this would prove far too difficult, with politicians unlikely to sanction such an initiative because it may bring forward what they're trying to stop anyway. Now, other plans have looked at harnessing the power of Yellowstone and somehow converting it to sustainable energy source. Like, for example, what we have in Long Valley Caldera, the California supervolcano, they do have a geothermal plant there. Now, one reported NASA plan involves drilling a 10-kilometer, 6-mile hole into Yellowstone and pumping water into it at a high pressure. But we know that there are areas of the magma roof being only 3 miles down from the surface. So what happens if you puncture the surface of the roof of the magma chamber? Now, this would circulate the water, returning it at an estimated temperature of 662 degrees Fahrenheit or 350 degrees Celsius. And slowly, day by day, it would extract the heat from the volcano. Estimates suggest that such a project would come at a cost of about $3.5 billion, but would generate electric power at competitive prices, and so comes with an enticing catch which could convince politicians to make the investment. But again, Mike Poland, the geologist in charge of Yellowstone Volcano Observatory, says as long as he's in charge of this volcano, no one's going to touch Yellowstone. This is by Joel Day on Express UK. Please leave your comments and thank you for your support.